Hello. Hi, everyone. Thanks for attending this talk. I'm Marius Vlad. I'm a senior software engineer at Collabora. I'm working on the graphics domain, predominantly on Western and Wayland. I'm part of the Western maintainers team, and I also maintain the AGL Wayland compositor. So the main focus of this talk is about window management using gRPC. I'm going to do a very quick overview of the AGL Wayland compositor, and afterwards I'll dive a bit into doing window management using gRPC. The last part of the talk is about streaming content to other devices and some alternatives way of doing that. So what is the AGL Wayland compositor? Is a libwestern-based compositor. We no longer use IVI shell, but instead we use libwestern-based compositor and rely on XDG shell for window management purposes, as all runtimes and toolkits have support for it. Applications do not require any kind of modifications, and any other additional functionality provided by two private extensions, AGL shell and AGL shell desktop, are provided with the AGL compositor. So there are two private extensions. It's AVA shell, which HMI implements, and this is similar to what you'll find in the desktop environment. It handles backgrounds and panels. It also does other things, like it activates the window it puts forward the window that you want to display and puts everything behind it, and it delays presentation until the client can tell the compositor that it's ready to start displaying. The other extension, AGL Shell Desktop, is there to allow additional window management. Rather than just setting the window maximized as we have it in the AGL compositor and starting up, we can also do it so they can behave like dialog pop-ups, split, or if you like, to place windows to other outputs either locally or remote. It also allows to, receive events from the compositor for different application states. And just like the first extension, it can activate and deactivate other clients. The difference is that this private extension can be used by all other clients, while the main one, the AGL shell one, is only for HMIs, or what I call the shell client. Now, this diagram shows how the compositor stacks different surfaces with the help of these private extensions. On the left is the HMI with distinct surfaces, each assigned in a different layer. And these layers are similar to what you'll find in IVI shell. They have different stacking position in terms of z-axis. Regular application would be stacked on top of each other. And using the private extension, you basically let the compositor know that you would like to display one of these surfaces. On the right, you'll see the other private extension, the AGL Shell Desktop one, with different application roles like split here and pop-up and dialog. Now, why do you have these two different extensions? Well, the main problem is that you cannot have the same surface managed by multiple clients. That's a thing that needs to stay, but in the same time, you like applications to modify their own Windows state and also other clients' Windows state, like making them float, pop up, full screen, split, and placed on other outputs. Now, this is a bit problematic because we kind of need to implement, we need to implement two different private extensions, AGL Shell and AGL Shell Desktop. AGL Shell Desktop requires access to Wayland primitives, and this isn't always that easy to do. Clients need to implement the client-side implementation of the extension, and this probably can be done using some kind of a wrapper library. This still remains the fact. And for some time now, the main extension has been neglected, and all the additional functionality has been added into the other private extension, like status events and additional surface roles. So the question is if we can do better, and obviously that's why I'm giving this talk. It's obviously possible. The idea being is to have just one single protocol, but multiple surfaces, and I'm going to talk about why we need multiple surfaces a bit later. Now, we switched to using gRPC as our global IPC in the AGL project, which is far more suitable. You can use it from different language runtimes, and this is sufficient reason for me to avoid having two distinct private extensions and just rely on using one. And now we go straight into doing window management with gRPC. So the first thing would be to migrate and reuse any functionality that I've been adding into the second extension, and well, bring it or add it into the main one. We also need to maintain that surface management by the AGL shell. I mean, there is no way around that. You cannot have two clients manage the same Wayland surface. And the idea is to have this helper RPC client, which proxies RPC calls to Wayland calls. So this proxy RPC calls is a distinct client. Rather than writing the gRPC implementation in the compositor, this is a distinct client that can be compiled out if that's well, if you don't really want to use it. The main reason for keeping it aside from the compositor is that to avoid dealing with multi-threading issues. Also, in case you would like to compile it out and you don't want to have it inside of the compositor, this is also an option. So on one side it implements the AGL shell Wayland protocol, and on the other side it implements the gRPC protocol. The most trickiest bit of adding this gRPC proxy helper is to provide a way to allow clients to bind to the AGL shell protocol. That is, to allow multiple clients to bind to the AGL shell protocol. And the way I solved this is to add another interface into the same protocol spec. And this interface allows the gRPC proxy to connect to the compositor, have this protocol dance where it tells the compositor that it also wants to bind to the AGL shell protocol, and if the client gives it an OK, it can further continue with binding to the AGL shell protocol and proceed further. And this is what this diagram basically shows. Right at the end, the client would like to do an activation gRPC call, and before that, you'll see that the gRPC proxy client has to have some protocol exchange between the compositor and itself to be able to issue that AGL shell activate app request. If you like to find out more, you can take a look at the protocol spec and the implementation, of course. Now, what we have basically currently, we migrated those application status events into the main protocol, and we already use that on Qt platform and on Chromium, I believe. Doing that also helps remove an implicit activation we have in the compositor. When you try to start an application, by default the compositor will see that event happening, and it will implicitly activate and bring forward the surface. Now with this application status events, the shell client is the one that controls that's behavior. It will get a notification from the compositor that the application has started, and it can well, display it. I guess the only remaining platform here to add that is Flutter, but that's something we plan on adding in this year. The gRPC implementation also has this application status events, and we currently have the activation. We have float and pop-up role. Lately, I've been adding full screen, and the transitioning between these, you can dynamically go from the normal default maximized state to full screen to float, and you can change between them dynamically at ease, basically. In the future, like I've said, Flutter is the one that's missing those status events, and to be able to do this startup and activation correctly without the compositor actually having any role in it. And yeah, full screen, I already have a merge request for that. We are missing the split functionality. Once that's also well done, we are basically in parity with the AGL shell desktop protocol, and we can basically deprecate it and remove it entirely. This is the protobuf protocol. I guess the one to mention here, when I've started adding this API like float and full screen, I noticed that we also need well, a request to tell the compositor to go back to the original state, and this is the set app normal, basically. The normal state when the application are starting with the AGL compositor are maximized, and they fill up what we call an activation area. The last subscription method here is the application status state, which basically maps one-to-one to the compositor events. You would register to, well, you subscribe to this application status events if you like to be notified when the application has started and it's been activated, deactivated, or, well, terminated, has been closed. Right, so the last part of my talk is about streaming content to other devices and alternatives to Waltham. But before I well, explain a bit what Waltham is, let's see how well the compositor does streaming between different devices. So we use the Weston's plugin, remoting plugin, which is basically a GStreamer plugin. It uses libweston DRM virtual API and talks to the DRM backend, basically using DMA file descriptors. It creates a GStreamer pipeline. Here on the slide you see, well, incorrectly, we should be here like remote output rather than just output. It's a section entry in the compositor ini configuration file where we tell it to create an output called remote one, and we use a special section entry called AGL shell app ID to place that application ID here, like the Western terminal, on that specific output. We can also do that programmatically from the AGL shell desktop and yeah, using the gRPC calls. The activation request has an application, activation request message which contains the application ID, but also the output in terms of, a human readable output. Right, and that was on the server side. This is on the client side. On the client side, we also use an AGL Wayland compositor, so we need a Wayland client. This client is set as floating, positioned in the certain location. It uses Wayland sync, obviously, to display incoming buffers, obviously because we're using the GStreamer pipeline. But the question is here, how do we handle input? So we have this dumb device, this client device. It's just talking with the server on the network. We don't have any direct connection to the input devices on the main system. And how do we relay this kind of input from that client to the remote server? And this is where Waltham comes in. which is IPC library similar to Wayland, but it's being developed with networking in mind. It works over TCP sockets rather than on a Unix socket like Wayland does, and it makes use of the XMLs to describe the protocol similar to Wayland. Yeah, it's an asynchronous architectures, and similar to Wayland, it has this object-oriented design. Now, the problem with Waltham is that there are no maintainers for it, and there are no, well, current new users that we are well aware of that. And it requires a lot of boilerplate to be able to provide a well working solution in implementation. It doesn't provide an event loop. The registry itself, it's the left out for the library. You need to also implement that. So, and there's no multi-threading support. Right, you need to do all of that in the client and in the server to be able to have this working solution. On the client side, you will need to well handle any incoming data over the streamer pipeline and display that to the compositor, provide an implementation for Waltham. You need to process inputs and send them back over the network. And the thing is that the client actually is the server because it's waiting for incoming buffer connections from the other side, from the remoting plugin. On the server side, we also use a Western plugin. We create a plugin specifically for this. So on the server side, we have two plugins. This is the remoting plugin, which streams the buffers, but also this this plugin to receive inputs, and it acts also as a synchronization between the local and the remote instance. It receives events from the client and delivers them to the application. Yeah. So as you can see, having this Waltham is Waltham use case is pretty well complicated. Now, I've been starting thinking on what would be the alternative to Waltham, and one thing that well popped into my mind was Pipewire. We have a plugin in Western basically for Pipewire, which we use to share output and an application. Pipewire is a local IPC. It doesn't talk, well, it doesn't know about the network. We will still need some kind of a helper client to stream buffers over the network. But that would be rather easy. It would be similar to what we did with the gRPC proxy helper client would happen as well as here. Would the compositor will start up this helper client and will basically be the same. We don't have any compression with Pipewire, so this would be a thing to improve an upstream in the Webstone. There's no DMA buff. We're just doing a map. Another thing to improve in Western, but the biggest hurdle would be that how do we actually relay input from the remote device to the local one? So talking a bit with the upstream about this, it doesn't seem really that feasible, and ultimately I've started to look into some other technologies, and these are obviously RDP and VNC, which are like established ways of doing this graphical sharing, which also carry input. You have compression out of the box in the library, and libwestern supports both RDP and these VNC backends. So technically, it wouldn't be that hard to have this RDP and VNC. But there are some steps which, well, we need to take in order to ensure that works. So the thing is that even though we support VNC and RDP backend, there's no way of loading these backends simultaneously in the same time. That is because we would need locally to be able to use the DRM backend and make use of what hardware gives us in terms of doing direct scan out of the buffers using hardware planes. And this is the local head, how as we call it, a local output with the DRM backend. But also we will need remote head using this RDP backend. and the ability to load this in the same time is something that we have. There's someone working on that. It's basically a merge request, but it's not really well merged, and I don't know well the status of it as it is now. On the client side, similar to what we have with Waltham, we will need a native Wayland client, either using VRDP or using any VNC implementation. We're going to use gRPC, proxy, that window management using gRPC proxy to be able to make it float and positioning whatever we want. And what's basically left for me to do is to try to experiment with these and try to look, at least in terms of compression, which one of these technologies seems better or works better over networking. I suppose some of them would work better than the others, depending on the resolution. For instance, if you have 4K resolution or something like that, probably some of them, probably one of them would work better than the other. That's actually remains to be seen. Yeah, I guess that was it. Thanks for watching.